Number 10, it wants us to find out, is this a redox reaction? And if it is, to figure out what's being oxidized and what's being reduced. So the best way to approach this is probably to assign oxidation numbers to everything in it. So we're going to do a few. I'm going to do the first example, but the other ones you can do. Bromine is -1, so this phosphorus is +3. Water is -2. Hydrogen is +1. Oxygen is -2. Hydrogen is +1. So that means we got to do a little bit of work underneath here. And it looks to me like the phosphorus is going to be +3. Like that. And then bromine is -1. Hydrogen is +1. So we finished assigning all of our oxidation numbers. And remember that the work on the bottom we don't need, so we'll get rid of that. Now we have to decide what's being oxidized or reduced, or if anything. So we're looking for things that are changing oxidation state. Bromine, or phosphorus? Nope. Bromine? Nope. And if we keep going down the line, let's see. Oxygen? Nope. It's -2 everywhere. And hydrogen is +1 everywhere. So it looks like this one is not a redox reaction. So therefore we just choose not a redox reaction. Let's see if that's a choice. Oh, it is a choice. Right there. Right there. So we can choose that one if we want to. Now this maybe isn't the best example, because what do you do if it was a redox reaction? And what you do if it was a redox reaction, like say for instance we had, well, let's not do phosphorus because it'll confuse people to think that this might be a redox reaction. Let's say you had fluorine going to fluorine -1. You remember that we're trying to see if it gains or loses electrons, and in this case it's going from 0 to 1, so it's becoming more negative, and electrons are negative, so it must be gaining electrons. So this is according to oil rig. If it's gaining electrons, it must be reduction. So that's kind of how we tell.